In this 310 Copilot tutorial, we'll cover how to generate novel protein sequences using a method called ProtGPT2. Why would you want to do this? Well, protein space is incredibly large, so if you make sequences by sampling completely randomly from the common 20 amino acids, you're pretty much guaranteed to end up with something that will not express, purify, fold, or do anything of interest. Typically, you would be much better off screening natural sequences or small variations around natural sequences. With the rise of generative AI for biology, we can now explore more of the vast protein space beyond natural sequence islands. To get started, you can simply ask Copilot to generate a random protein. As a default, it runs ProtGPT2 and gives back a sequence. You can also ask Copilot to make 3 more sequences with ProtGPT2. Note, due to resources, we limit generations from ProtGPT2 and other methods to no more than 3 at a time for now. Based on just the sequences, you can get an idea of what these proteins might be by predicting their function. Specifically, here I'll ask Copilot what the predicted function of P3 versus P4 is. This runs protNLM and gives back a table, one for each protein. P3 here looks like a transposase, and P4 seems to be a little bit less well-defined. Let's take a look at their structures and see if that gives us any insight. You can ask Copilot to fold P3 and P4 and compare them. This runs 3 separate commands in the background, namely ESMFold on P3, then ESMFold on P4, and then compare, which is actually a number of calculations, including protNLM. Because we asked for a comparison, Copilot tries to compare the sequences in a new layer, highlighting differences in red. In this case, because the sequences are so different from each other, most of the sequence is in red. The structures are also automatically aligned, but again, because these two are so different from each other, there isn't much of an alignment to see. In these cases, you can turn on and off the visualizations of each entity in a layer by clicking on the little circle to the left of the name to make it easier to see one structure at a time. I like how P6 looks, so let's ask Copilot what proteins are structurally similar to P6. This runs FoldSeek, which is a structure-based lookup against the PDB database. This is a database of experimentally determined protein structures. It returns the top 3 results, namely the PDB ID and chain ID for the match, the E-value, and the TM score. The E-value is a measure of the statistical significance, with lower being more significant. Usually less than 0.001 would be considered significant. The TM score is a measure of structural similarity, 1 being perfectly aligned and 0 being perfectly unaligned. Usually, more than 0.5 would be considered structurally similar. If you want to explore all the sequences and structures further, you can ask Copilot to export all, which will produce a link to a zip file with all of the relevant results. And finally, if you want to share your section, you just need to copy and send the web URL, and you will be able to go back to the session anytime. Thank you for watching, and see you in the next one.